Welcome to Safety for Teaching Laboratories training. My name is Wendy McCoy and I'm the Laboratory Safety Manager. My staff and I in the Laboratory Safety Division of Environmental Health, Safety, and Risk Management are concerned with the safety of students, faculty, and staff in UTSA's laboratories. Please pay close attention to the following training course. It is designed to provide you with information on hazard identification, personal protective equipment, lab safety guidelines, emergency equipment and response, and waste management.
The Laboratory Safety Division of the Office of Environmental Health, Safety, and Risk Management has developed a set of guidelines to ensure the safety of faculty, staff, and students working in university laboratories. It is critically important to become familiar with these guidelines as you begin working in a lab environment. By following these guidelines, you will learn the various hazards, routes of exposure, as well as acute or chronic exposure information of laboratory chemicals. This information is on the container label, the associated material safety data sheet, or by asking your teaching assistant or lab supervisor. You may also call the safety office at 458-5250, or contact the manufacturer or distributor of the chemical if needed. When looking at an MSDS, review the following sections very closely. Section 3, Hazards Identification. Section 4, First Aid Measures. Section 6, Accidental Release Measures. Section 8, Exposure Controls Personal Protection. Section 10, Stability and Reactivity, and Section 11, Toxicological Information. It is important to know the different types of chemical hazards that exist in a lab environment. Additionally, it is important to know a chemical may potentially have more than one of these hazards. A carcinogen like benzene, formaldehyde, or chloroform causes cancer in humans or animals. A toxic chemical will cause death or disease at certain concentrations. A corrosive like sulfuric and hydrochloric acid will cause destruction of living tissue or metals. Exposure to a teratogen like lead can cause physical defects in a developing embryo. Anesthetics like chloroform and ether depress the central nervous system, producing a loss of sensation or feeling. Mutagens like ethidium bromide and formaldehyde induce genetic mutations in DNA. An irritant will cause a reversible inflammatory effect on living tissue. A sensitizer causes an allergic reaction on the skin or to the respiratory system. The following physical hazards may also be associated with laboratory chemicals. Flammable liquids like alcohols, acetone, and ether classify as chemicals that can ignite below 141 degrees Fahrenheit. A flammable solid like sulfur, magnesium, or aluminum can catch fire through friction, absorption of moisture, and when ignited burns vigorously enough to create a serious hazard. A water reactive means that when the chemical reacts with water, it releases a gas that is either flammable or presents a serious health hazard. An oxidizer will promote the combustion of other materials by releasing oxygen when heated. An explosive can cause the sudden release of pressure, gas, and heat when subjected to sudden shock, pressure, or high temperature. A chemical's route of exposure is the means through which a chemical causes harm. Chemical route of exposures include inhalation of fumes, absorption through the skin, injection, or skin penetration by a needle or broken glass, and ingestion. Chemicals can present two forms of hazard upon exposure. An acute hazard is a high dose over a short duration, and a chronic hazard is a low dose over a long duration. The toxicology of a chemical is very important to understand as well. If a chemical has an LD50 of less than 50 milligrams per kilogram, or an LC50 of less than 200 parts per million, the chemical is considered very toxic, and extreme caution should be used when handling these dangerous substances. Toxicology numbers are calculated by exposing a group of laboratory animals to a particular chemical. When 50% of the population dies, the LD50 or LC50 is set for that particular chemical. Remember, when working with chemicals, you need to be aware of the hazards. In class, you learned that hydrofluoric acid is a weak acid. This often misleads many into thinking that it is a relatively safe chemical. However, this chemical is very dangerous and readily penetrates human skin, allowing it to destroy soft tissues and decalcify bone. Inhalation of hydrofluoric acid can even be fatal. So always research the chemicals you will be using and never assume that any chemical is safe. There are various methods of protecting yourself in the lab. Look for postings that inform you of certain dangers. Each lab is equipped with engineering controls such as flammable cabinets for chemical storage and fume hoods to vent noxious fumes away from you while you are working. Personal protective equipment, or PPE, is another key to protecting yourself. There are many types of PPE that should always be worn while working in the lab. They include safety goggles, gloves, lab coats, and perhaps respiratory protection if deemed necessary by the chemical in question. Most importantly, wearing shorts or sandals is not permitted in the lab. Your feet and legs must be completely covered at all times.
Hey Greg, you can't come in here dressed like that. There's a dress code.
Oh, I forgot, sorry.
This is an example of what can happen if you spill chemicals on your foot. Chemists are not the only group of researchers who use dangerous chemicals in the lab. Biologists use very hazardous chemicals in their research as well. Phenol compounds commonly used in DNA extraction can cause third-degree burns and even cancer. Therefore, always verify the hazards associated with chemicals you work with. There are many documented examples of serious or fatal injuries while working in laboratories. And while not all accidents will be avoided, the risks can be minimized by following lab safety guidelines. For example, there is no eating, drinking, or applying cosmetics in the lab. Always wash hands after working with or around chemicals and before leaving the lab. To avoid the spread of contamination, keep all PPE in the laboratory. Keep drawers and cabinet doors closed. Label all beakers, flasks, and test tubes with their contents. Never store acids and bases in the same cabinet. Always dispose of waste in properly labeled containers. Remove gloves before handling items such as telephones, doorknobs, or computers. Students should never work alone. Wear appropriate PPE. Never store hazardous chemicals on the floor. Never pipette by mouth. Always use appropriate caution and procedures while working with and around gas cylinders. Before working with glassware, inspect for cracks, chips, or fractures. If the glassware is broken, let your instructor know and dispose of it properly in the marked broken glass containers. In the event of a chemical spill, follow these steps. Remain calm. Avoid breathing vapors or dust. If spill is flammable, turn off all ignition and heat sources. Evacuate all personnel from the lab. If possible, try to contain the spill. Seek medical aid for injured by calling UTSA Emergency Services at 458-4911. Have the chemical MSDS available for emergency responders. Transport patient to Student Health Services or emergency room. If spill is on your person, flush appropriately with copious amounts of water for at least 15 minutes at nearest safety shower or eye wash. While being rinsed, remove all contaminated clothing. Notify the safety office at 458-5250. The most common type of fire extinguisher on campus is ABC. Some labs are equipped with CO2 or BC. Only attempt to extinguish small fires that you feel comfortable fighting and use the appropriate extinguisher for the type of fire presented. If you choose to fight a fire, remember the word pass. Pull the pin, aim the nozzle, squeeze the handle, sweep from side to side. Remember, a fire extinguisher only has enough media for 8 to 12 seconds of operation. Never pour any chemicals, solutions, or waste down any drain. Do not discard empty chemical containers in regular trash. Evaporation of solvents is prohibited. Label all waste containers with waste and contents, including concentration, to prevent unknowns. Add waste only to the appropriate labeled container. There are two types of chemical waste that should never be combined. Halogenated organic waste has one or more carbon atoms that are covalently bonded to one or more halogen atoms such as fluorine, chlorine, bromine, and iodine. Non-halogenated organic waste has one or more carbon atoms bonded to a non-halogen atom. Combining these two types of waste creates a very toxic compound that is difficult to remediate. Waste bottles must be closed and labeled with the word waste and contents of the bottle. Finally, do not hesitate to speak with your instructor or call the safety office at 458-5250 to report an accident or injury. If you notice a strong, lasting odor, if you witness an unsafe act, or if a major spill of more than 1 liter occurs in any work environment.
Seemingly small incidents in laboratories can have long-reaching effects. My staff and I have learned this firsthand in our years of work in academic and industrial laboratories. I hope you found this training informative and will use the information provided to assist in ensuring your safety in the laboratory. If you ever have any questions or concerns about laboratory safety, please feel free to contact me or my staff. Our contact information is available at our website. I wish you success in your career at UTSA.